Hello, today we are going to go over how to solve systems of equations by graphing, and we're also going to review how to solve systems of equations by the substitution method and the elimination method. So this should be kind of a review. You should have learned this in middle school, how to do these different methods, but today will just be a good review for that. So when you are solving a system of equations, remember a system means that you're going to have multiple functions that you're looking at, multiple equations. And when you're solving, essentially what you're doing is you're seeing when do those two functions intersect with each other. So that will give you the solution. You will be given a few different formats of how to solve systems of equations. One is if they give you a table like this, where here we have a table, and this table you'll see represents f of x, and this table represents g of x. So in this first example, it says f of x is the equation x squared minus 3, and g of x is the equation negative 1/2 x plus 1. And if I were to plug in x values into each of these x's in my equations, these would be the outputs or the y values I would get. So again, when we're solving a system, essentially what you're doing is seeing when the two graphs would cross each other and when they would intersect. So if you're given a table like this, what you're going to do is literally just find if they have the same point anywhere. So at negative 3 for x, is their y value the same? Which, no, it's not. So I would just keep going down my list to see, do they ever intersect at the same spot? And if they do, so here we see one, these 2 points match, that means on the graph, they're crossing at the same point. Always check through to see if there's more though, because sometimes there can be more than one intersection. So our solution would be the point 1, negative 2. So those ones are really easy to do. And then sometimes we ask to graph. So using technology or your calculator, you are going to put in the equations. If you don't have a graphing calculator for your technology, you can use Desmos, the app, or you can go to desmos.com and graph from there. But I'm going to grab my graphing calculator and we're going to type in both of these equations. So on the first one we have x squared plus x minus 12. And then go down to the next row, and this one is a log button. So the log button is down here by the number 7. So I'm going to do log of x plus 5. And then close my parenthesis, and then do the minus 3 on the outside. And then we're going to graph. So there's the first function, and then here is the log function. So, and for some reason, graphing calculators don't do the bottom half of the log function. It's kind of silly, but this one does go straight down from here. So really this graph is coming up through here and then bending, but we have an intersection here and an intersection here. So to find those exact 2 points, we are going to go back to this calc menu that we've used this unit. So we're going to push second and then calc. And this time we're going to look for the intersection. So we're going to go down to intersect. And then, light's kind of bright. You should have a little dot. Mine's not showing up, so I need to move my cursor until I see it. So I think it was down here beneath where I could see this curve. So sometimes you might have to move your arrow keys until you can find that dot. But right now it says I'm on the first curve, which was that parabola. So you're trying to get as close as you can to where they're intersecting. So see how I can't get quite on top of that intersection? That's okay, just get as close as I can, which would be that point. Now you're on the second curve, which is this logarithm curve. So again, get as close as you can to where you think that intersection is, push enter, and then this third time they're going to have you guess. So you're going to essentially do this 3 times on the first curve, on the second curve, and then a guess point. And then this is going to be your intersection. And it will just tell you what to round to. Most of the time it's 2 decimals. So I'm going to say this is at negative 3.57 for x, be my intersection. And then for y, negative 2.84. And then it did say just to draw a rough sketch. I'm going to do a really rough sketch, nothing super fancy. So we, on our first equation, we had a parabola, and then we had our logarithm bending through like this. So there's our 2 graphs. And we have an intersection here at this first point, which doesn't even match up to my actual answer, but that's okay. I'm just going to label it. And I'm going to say this point is at negative 3.57, comma, negative 2.84. And then now I need to go and find that second intersection over here. So we're just going to repeat the process by going to second, calc, and then down to intersect. And this time we're going to move this dot over to the second intersection. So scroll over until you can get that dot over there. So again, we can't get right on it, so just pick one that you think is closer. Let's just go with this one. And then now we're on the second curve, so get that close to where you think the intersection is and guess. And then guess a third time, push enter again, and then we have this intersection. So I'm going to do 2.68 and negative 2.11. So that would be our second intersections. So again, sometimes you'll have just one intersection, sometimes you could have 3 intersections, just it totally depends on what the graphs look like and what functions you have. So this one is at 2.68 comma negative 2.11. Okay. Let's do another example of graphing. So notice this time we have an absolute value function, and then this one we have a rational. So let's go and type those in. So let's clear out our old ones. And then for this one, we're going to do the 2/3. And then to get your absolute value function, you need to go to math. And then we're going to go over to the number column. And it's this first one, abs, will be your absolute value. And see that it'll give you those 2 little lines. And then a box to type in the inside part. So on the inside we want x plus 1, and then use your arrow key to go past that line, and now we want to do the -8. So just make sure that that -8 is after that absolute value line and not inside with the +1, or you'll get messed up. Okay, and then for our g of x, we have a rational, so we can either type it as 2x squared and then divided by, but remember, your calculator is kind of picky on how you type things in. In order to say that this entire polynomial is in the denominator, we do need parentheses around it. So I'm going to put parenthesis x squared, oops, wrong one, x squared minus 4x, and then plus 45. And then close your parentheses. So now it knows that whole thing is in the denominator. And then we will graph it. So here is that absolute value function doing that V shape. And then here comes our rational. We get kind of a funny little swoopy shape. So notice in my window right now, nothing is intersecting. So I think these 2 intersect off of where our screen is showing, somewhere over here and somewhere over here. So we need to make our window wider. So your window is this button. Right now I'm just going from -10 to 10, which isn't very big. Let's go from like let's do -30 just to be safe. Oops. To +30. And this scale is saying we're just counting by ones. And then for our y min and our y max, let's say we're going for -30 down and up to +30, and we're just counting by ones again. And so now we'll graph it again. So there's that V shape coming through. And then here is the rational. We can barely even see it, it's so close. So there is our intersection here and here. So I'm actually going to zoom in a little bit more so we don't have it so far out. So let's go -20 to +20. So you might have to mess around with this a little bit until you get the window how you like it. If you're on Desmos, you can just zoom in and out on the screen, which is kind of convenient. Okay, so there's an intersection and there's our other intersection, so we can see a little bit better with that window. So now we just need to go find those by going to the calc menu, down to intersect, and let's just do this left one first. So see my little dot came up. I'm going to scroll along the first equations curve over to where they intersect. So just get as close as you can. So either of those would probably be good, and push enter. Now we're on the second curve. Push enter, and then guess, push enter. So we have an intersection -15.05 and then 1.37. So that would be our first part. And then now let's get the second one because there are 2 answers on this one. So just repeat, go to second calc, down to number 5, intersect. Now scroll over. This is where we need like awkward elevator music to be playing in the background while we wait. Almost there. Okay, so we're on the first curve, push enter. Second curve, push enter, and then guess, push enter. And we get our second intersection. So 14.19 and 2.12. So second point, 14.19 and 2.12. And then again, just let's just do a really ugly, that's really bad, sketch here. So we have our V shape coming through, and then this one kind of almost looked like a little bird. Oh, it was like bending through. And we had those 2 intersections. So that is the graphing. But I also want to review how to solve a system of equations with the substitution method and elimination method. So again, you should have learned how to do these in middle school. This should be a review for you. So let's just practice. With substitution, the method, essentially what you're going to do is you want to solve for one of the equations for either x or y, and then take it and substitute it back into the other equation. So when you're looking at your 2 equations, I like to find one where a variable would be easy to get by itself. So like looking at this y is almost alone except for that 4x. So just to get that y alone, all I would need to do is minus that 4x over. So that's going to be a really easy one to work with. So if I minus that 4x over to the other side, I get y equals 24 minus 4x. So once I have that solved for y, I'm going to take this piece, because we're saying y is equal to this, and I'm going to substitute it into the other equation. So if I do that, I keep the 2x, but then I'm going to minus 3, but then instead of y, I'm going to substitute in the 24 minus 4x equal to -2. And then the whole reason we did that is now I have no y's in this equation, I just have x's. So we're going to simplify. So first we need to distribute that -3 through. So we have 2x, and then 3 times 24, 72. And then -3 times -4x will turn to a positive 12x. And then from here, we just need to start combining our like terms, and we're going to start solving for x. So I have 2x plus 12x. That gives me a total of 14x minus 72 equals -2. But let's start getting that x alone. So let's add 72 over. So those cancel. We get 14x is equal to -2 plus 72, which is 70. And then now, solve for x, we need to get rid of that 14. We'll divide by 14. And so if we divide 70 divided by 14, that gives us x equals 5. But remember, when you're solving a system, you're finding where the two equations would be intersecting with each other. So if I have an x value, I also need a y value. Right now I'm only halfway done because I only have the x. So now to get the y value, we need to plug x in to one of the equations. So I usually think plugging it back into this one where you solved for y is usually the easiest one to do. So if I plug that in, I get y equals 24 minus 4, but instead of x, I'm going to plug in the 5 that we just solved for. So 4 times 5 is 20. 24 minus 20 is 4. So y equals 4. So we have x equals 5, y equals 4. So remember, this is a point. So we would want to write it as an ordered pair, 5, 4. So essentially, if I graph these two lines, they would cross at the point 5, 4. So that's the substitution method. Let's look at the elimination method. Some people call this also the addition method. Let me write elimination on here. Because when you're doing the elimination method, essentially what you're doing is adding the two equations together or subtracting them. So you're trying to eliminate one of the variables by either adding or subtracting. So if I look at this, these two equations, I have an x here and an x here. So if I subtract this row, what happens is x minus x, those are going to cancel, and then I don't have any x's left. So now, remember, we're subtracting. I'm also subtracting this, and I'm also subtracting the 16. If I have negative 2y and I subtract, not add, but subtract 3y, I get a negative 5y. And then negative 9 subtract 16 is going to be a negative 25. So make sure you don't mess your signs up. Sometimes that can be tricky when you're doing the elimination method. And now essentially we solve for y. So I'm going to get rid of that negative 5y by dividing by negative 5. So I get y equals negative 25 divided by negative 5, which is positive 5. But just like on the last example, I only have my y value, so I'm only halfway done. I need to get the x value. So we need to get x by plugging in y. So you can pick either equation to plug it into. On this one, there's probably not much of a difference. So let's plug it in. Let's plug in y equals 5. I'm just going to do the top row. So I'm going to get x minus 2y, but instead of the y, I'm going to plug 5 in. Equals negative 9. Well, negative 2 times 5 is negative 10. So I have x minus 10 equals negative 9. So solving for x, we need to add that 10 over. So those cancel, and I get x equals negative 9 plus 10, which is 1. So we have y equals 5, x equals 1. But remember, we want to write that as an ordered pair. So remember, x always goes first, even though in our ordered pair, even though we found it second. So my point is going to be at 1, 5, and that would be my answer. So elimination method, substitution method, graphing, they're all going to get you the same result because what you're finding is where the two equations would cross each other on the graph. So you don't really need to know all of the methods. Just pick whichever one is your favorite and solve from there. Sometimes there's like pros and cons to each method. If you just have lines, like these are all just linear x's and y's, solving by hand is really easy. But if we look back at these ones, if I tried to solve one of these equations by substitution or elimination, that's going to be really hard to do when I have an absolute value function and a rational function. Imagine trying to solve for x there by substitution or elimination. So you could still do it, it's just not going to be easy. So it's kind of nice to know the 3 different methods just because some are going to be easier than others depending on what your equations look like. So, but hopefully that was a good review for you guys. Go ahead and start the homework for this section, and if you have any questions, as always, please feel free to reach out to me. This is the last section of our unit, so we will be getting ready for our test now. So make sure to reach out to me if you have any questions on anything from this unit, and I can get some help for you. Hope you guys have a good day. See you later.